Section P.8, modeling with equations. So we're going to be looking at using equations to solve problems. This is usually students' least favorite part of math, dealing with word problems, but we will get through it. So problem solving with equations, it says a model is a mathematical representation of a real-world situation. We obtain models by translating from the ordinary language of English into the language of algebraic expressions. So some strategies for solving word problems. Some of the problems you're going to look at in this section are going to be pretty simple and easy. Some of them you have to think through. What is a process? So here's a process. Step 1, read the problem carefully several times until you can state in your own words what is given and what the problem is looking for. It says to let x or any variable represent one of the unknown quantities in the problem. So always read the problem. What do I know and what am I trying to figure out? It says step 2, if necessary, write expressions for any other unknown quantities in the problem in terms of x. So if you have two unknowns like an x and a y, then you want to be able to take that y and kind of relate it back where the only variable you're using is an x variable, because you only want one unknown to solve for. Step 3 says to write an equation in X that models the verbal conditions of the problem. Step 4 says to write the equation and answer the problem's question. And step 5, check the solutions in the original wording of the problem, not in the equation obtained from the words. So go back and make sure that the answer that you ended up with makes sense for the problem that you're solving. So let's take a look. Example 1. It says the median starting salary of a computer science major exceeds that of an education major by $21,000. The median starting salary of an economics major exceeds that of an education major by $14,000. Combined, their median starting salaries are $140,000. Now, this book was written quite a while ago, so I'm pretty sure those numbers have changed by now. So it says to determine the median starting salaries of education majors, computer science majors, and economic majors with bachelor's degrees. So we need to read and understand the problem. We obviously have 3 different majors that we're talking about, and they all kind of refer back to that education major, right? The computer science major exceeds that of an education major by $21,000. The median salary of an economics major exceeds that of an education major by $14,000. And then combined, their median salaries are $140,000. So let's see. Step 1, it says let x represent one of the unknown quantities. So they were all referring back to our education major. So let's let x represent that median starting salary. The median starting salary of an education major. And you could always shorthand that a little bit. So x is equal to education major. It says step 2, represent other unknown quantities in terms of x. So I'm going to go back and take a little look back up here. So let's see. The next one that they tell us about is a computer science exceeds the education major by $21,000. So that means our computer science person, right, that's our other unknown, is going to exceed, meaning adds with it the $21,000 to whatever our education major is, which we called X. So that means that we can say that our computer science, I'll call it comp sci, that is going to be whatever the education major is, X, added with 21. The other person that we have up here, let's see, it says the median starting salary of an economics major exceeds the education major by 14. So now we know our economics major, again, is going to add with our education major 14 this time. So economics, we'll call it econ, they are going to be whatever the education major is, but it's going to be 14 more. And it says step 3, write an equation in X that models the conditions. Well, we have however much our education majors make, added with our computer science majors, added with our econ majors, is going to equal that total amount that they told us. So our education major is X. Our computer science is that X plus 21. And our economics is X plus 14. And what was the total that they gave us? Let's see. We have combined all together, we have $140,000. So all together, we have $140,000. And we have a nice equation we can go ahead and start solving. So step 4 says to solve the equation and answer the question. So let's see, x plus x plus x, we end up with 3x. 21 and 14 is going to give us, so I got 35. That all equals 140, and so we can solve to figure out what x is. Subtracting 35, 3x is equal to 105. Dividing by 3, x is equal to, what do we got, 35? So that means the starting salary of an education major is $35,000. The starting salary of a computer science major, well, let's go back and see our computer science. Our computer science is whatever our education major was plus 21. Well, we just found out that our education major is 35. So if I take 35 and I add 21, so 35 plus 21, that gives us, what do we got? $56,000. And then our economics major, they were 14. So 35 added with 14. That's going to give us, what do we got? 49. So we end up with $49,000. And again, this is a little dated because, I forget what year this book came out, but every year those numbers end up going up just because of the cost of living and everything else in life continues to rise in terms of how much everything costs. So if I kind of just did a double quick check, if I took my 35 for my education, my 56 for my computer science, and my 49, right? They said our combined of all three of these has to be 140. Let's see, 9 and 6, that's 15, and 5 is 20. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep, 140 is equal to 140, right? We know we're okay. That was kind of an easy one, hopefully. All right, let's try another one. It says, after a 30% price reduction, you purchase a new computer for $840. What is the computer's price before the reduction? So let X represent one of the unknown quantities. Well, in this case, the unknown quantity, they want to know what is the computer's price before reduction. So X is going to be, how about we just call that the original price? Computer's price before reduction, original price of the computer. The original price of the computer. So step 2, represent other unknown quantities in terms of X. Well, in general, we have a new computer. And what do we know about it? Or the new price of the computer, I guess, not new computer. The new price says after a 30% reduction. That means that we need to figure out what is going to be that new price. Well, we had the price of the computer. So the original price of the computer we said was X. And then we are doing 30% reduction. So we need 30% of the price of the computer. And we need to reduce that price or deduct that price. We need to subtract 30%. Well, 30% times the price of the computer, X, would mean 0.3 or 0.30 of X. 30% of the computer I need to take off. So I have 100% of the price. I'm going to take away 30% of the price, which means that's going to leave us with what percentage of the price are we paying? This whole thing means that we're going to end up paying 70% of the original price is going to equal how much money are we paying? You purchase a new computer for $840. That allowed us to write an equation. We took the price of the computer, 100% of the price. We took off our 30% of the price, which leaves us with paying 70% of the price. Make sense? So now in step 4, it tells us to solve it. So if I were to take my 840 is equal to 0.7x and I divide by 0.7, we end up with x is equal to, throw it in a calculator, you would end up with 1,200. So the original price of the computer was $1,200. And again, they want us to check it. If I were to take my $1,200 computer and take away 30% of $1,200, will I end up getting $840? So let's see. I'll do a little quick calculation. If I were to take 1,200 and subtract 0.3 that multiplies with 1,200, $840. Looks good to me. So that ends up working out to $840 is equal to $840. Let's try another one. It says the length of a rectangular basketball court is 44 feet more than the width. If the perimeter of the basketball court is 288 feet, what are its dimensions? Well, we are talking about dimensions. Dimensions means they want to know what is the length and the width of the basketball court. They tell us about perimeter, which means that you might have to dig back through that long-term memory and see if you can remember some sort of formula. So it says let X represent one of the unknown quantities. Well, they give us information about the length. The length of a rectangular basketball court is 44 feet more than its width, but we don't know what the width is. So let's use X to represent our unknown, which is going to be the width. Whoops, I spelled that wrong. W-I-D-T-H. We are going to then be able to represent the length in regards to that width. It says that the length is 44 feet more than. Well, what does more than mean? More than means to add. The length is whatever the width is plus 44. And then we said in terms of perimeter, hopefully you know P is equal to twice the length and twice the width. The perimeter of a rectangle, you have two lengths and two widths. It tells us then that the perimeter is 288 feet. That's going to equal 2 times the length, which is X plus 44, plus 2 times the width, which in place of W we have an X. And now we have an equation that we can solve. Solve the equation. So let's see, 288 is going to equal, if I distribute out that 2, we would have a 2x plus 88 plus 2x. Combine some like terms, and while I'm at it, I'm going to move that 88 over. That's going to end up leaving us with 200 is equal to 4x. Dividing by 4, your x is going to equal 50. So if I was able to figure out the width of the basketball court is going to be 50 feet, then, let me move it over, 50 feet. The length, well, we set up here that the length was x plus 44. So the length, if I have x plus 44, that means I have 50 plus 44, which is going to end up giving us 94 feet, which means that the dimensions are 50 by 94, or 50 feet by 94 feet. And it says if we double check it, well, perimeter, we have 2 lengths and 2 widths, not necessarily in the same order, I just wrote them in, but 2 times the width plus 2 times the length then, is that going to end up giving us our 288 that we need? So 100 plus 2 times 94 is 188. Looks good to me. And one last type of problem we're going to look at is being able to, again, using a formula, using the Pythagorean theorem. It says the sum of the squares of the lengths of the legs of a right triangle equals the square of the length of the hypotenuse. If the legs have lengths A and B and the hypotenuse has length C, then A squared plus B squared equals C squared. You should be plenty familiar with that, Algebra 1, and doing some trig. So it says, for example, a radio tower is supported by 2 wires that are each 130 yards long and attached to the ground 50 yards from the base of the tower. How tall is the tower? Well, they're saying that we have our unknown is how tall is the tower, so we can use that as X. We are 50 yards from the base, so along the bottom here we'd have 50. And then we have 130 yards as our wire. Now, there's another wire that's attached as well, but that is, we don't need to use that 130 twice, right? So it wants to know how tall is the tower. So again, you guys know this stuff. A squared plus B squared is equal to C squared, right? Across from that right angle, that is always going to be your side C. Your hypotenuse is always the side by itself. And it doesn't matter which one you call A and which one you call B. So if I had a 50 squared plus an unknown squared, that's equal to 130 squared. 50 squared, that would be 25 with 2 zeros, plus x squared. 130 squared, well, 13 squared is 169, so I'd have 2 zeros after that. Subtract 2,500. Use a calculator if you really need. Learn some tricks with your brain if you can. If I take 169 and I subtract 2,500, let's see, we're going to be left with 14,400. And if I take the square root, now obviously if we're finding the length of a tower, we're not going to have a negative. So just because we're taking a square root in this case, we don't need to give the positive and the negative version of it because a height has to be a positive in this case. It's the length of something. I know that 144, the square root of that would be 12. So those 2 zeros means I get 1 0. So I'd have 120. And the units that they give us are yards. Always include your units.